Well, good morning, everyone. As you can see, my name is Andrew Campling. I work for 419 Consulting, which is a public policy and public affairs consultancy focused on the tech and telecom sectors. And I'm going to be talking to you today about developments in DNS privacy. Next slide, please. And specifically on that, I'm just going to give you a little bit of context in terms of why I think network operators ought to care about these developments, and then give you a run through some of the latest developments in encrypted DNS, various flavors of that, and some related technologies. Touch on a couple of other things that are coming. And then maybe just pose the rhetorical question whether technology alone can solve the problem of privacy, and talk about a couple of other things, and then signpost some additional information. Next slide, please. Okay, so firstly, though, by way of context, why should network operators care about the domain name system, the sort of telephone directory, if you will, of the internet? And in this context, I'm really thinking of both public and private network operators. So many of these comments will apply equally to ISPs as, say, an enterprise or someone running a home network. And I guess probably firstly, the DNS has, over the last many decades, been something of a backwater in terms of internet standards, having been sort of largely unchanged since its inception in terms of the basic protocol, albeit with many adaptations along the way. And sort of network operators have, by and large, sort of used the DNS of a control mechanism. For example, things like parental controls. If I'm thinking about a public network operator, malware filtering, cybersecurity, and various other options, things like zero rating of traffic, etc. Now, depending on your point of view, some of the recent changes and developments in DNS have been sort of very much focused on privacy. On the one hand, or perhaps more realistically in terms of the proponents, quite a lot around improving performance of applications, with privacy being arguably more of a byproduct than the sort of primary driver to some of the recent changes. There's also been the rise of some of the cloud-based DNS resolvers, so Google, Cloudflare, Quad9, etc. With Google, depending on which stats you believe, I think the APNIC stats suggest the Google resolver sees as much as 30% of global DNS traffic, which is probably makes it by far and away the biggest resolver operator globally. And from the perspective of the sort of network operator, as the sort of cloud-based resolvers have sort of taken market share, there is this sort of risk of network operators losing both visibility of traffic traversing their networks, as I say, public or private, and as a consequence of loss of visibility, loss of control of that network traffic. And that in particular, I know, is exercising sort of concern within some network operators, if it means that the perceived performance of networks might actually degrade from an end user experience point of view. Next slide, please. So just as a reminder, to give you sort of an explanation as to what exactly encrypted DNS is, you'll see the chart at the top of the slide is traditional DNS over port 53, for those of you familiar with DNS, where the end user client sends a DNS request which traverses the internet to a resolver, and then comes back with the requisite IP address, and that's sent as clear text. and therefore is vulnerable to a passive observer potentially being able to sort of track what's going on, what that particular user is doing in terms of what sites they're accessing, etc. There've been a number of recent developments in encrypted DNS, perhaps one of the better known ones being DNS over HTTPS, and that encrypts all of that traffic. So if you look at the bottom right diagram, you'll see that the observer is no longer able to sort of see what sites the user is accessing. Although it's worth bearing in mind that although an observer can't see that information, the resolver operator absolutely can still see what the user is accessing, so is well placed to track the activity of the user. And again, depending on your point of view, some people would point out that given the larger sort of business activities of some of the cloud-based resolver operators, really all encrypted DNS is doing is stopping their rivals from monetizing the sites that the users are accessing, but the resolver operator, the encrypted resolver operator, is still perfectly able to do so if that's part of their business model. Next slide, please. Now, looking at client software, as that's evolved over the last couple of years or so, with the move to encrypted DNS, that requires the client software to sort of change the resolver that it's using from perhaps the one operated by, let's say, an ISP to an alternative resolver. The best known example probably being Firefox, which was sort of pretty much first to market as a browser in supporting encrypted DNS. And in the US, it changes by default to an encrypted DNS resolver, putting up a dialog box not dissimilar to the one you'll see on the slide, which presents you with a nice comfortable blue box to tick to say you're happy to get better protection and move on. Of course, what it doesn't do is to consider whether the resolver you're already using is encrypted, and nor does it consider whether the resolver you're using offers, for example, malware filtering. And if it switches you, originally the default it would move you to would be the Cloudflare Quad 1 resolver, which, whilst it's encrypted, certainly doesn't do malware filtering. So arguably, you might, depending on your starting position, end up worse off by that sort of move to a sort of greater privacy. It's by no means foolproof. Chrome and Windows are taking a slightly different approach with their browser in the case of sort of Google Chrome, and Windows 10, Windows 11 in the case of Microsoft. They do something at the moment called same provider auto upgrade, where rather than just sort of changing you to a completely different resolver, they examine the resolver you're currently using, and through the use of a lookup table, if that resolver operator also has an encrypted option, they'll move you automatically to the encrypted option operated by the same resolver as the one you're currently on the assumption that the existing policies will carry forward to the encrypted version. That's arguably a better option in terms of sort of not presenting the user with any surprises in the user experience, but it does require Google or Microsoft to maintain a sort of manual list of resolvers and so on. So it's not especially scalable. And currently the industry is developing some resolver discovery standards within the Internet Engineering Task Force, the IETF, in its ADD working group. A number of those are moving forward at the moment. The one that's most advanced is called Discovery of Designated Resolvers, or DDR. And that's already being piloted by Cisco, Microsoft, Quad 9 and Cloudflare. with sort of the one slightly less advanced called Discovery of Network Resolvers, or DNR. Also under development, also making progress, but not quite so far forward yet. The latter one being probably more useful in the UK context because it will support DNS forwarders and private IP addresses, which is sort of rather more common as a configuration, certainly in residential and small business environments outside of the US. So that's one to probably keep tabs on, which will be rather more useful, as I say, in the UK market context. There are various others, including one supporting split horizon DNS, which is perhaps more prevalent in the enterprise space. So lots of activity there, which will put discovery of resolvers more in the hands of users, which is probably where it better sits than the client software making decisions for it. Next slide, please. So although DOE, or DNS over HTTPS, has sort of gained quite a lot of publicity over the last 18 months, 2 years or so, that there are other developments underway. DNS over QUIC, or DOC, is almost finished now in terms of the standard. It's pretty much finalized. AdGuard, in fact, claimed the first deployment something like 15 months or so ago of a pre-standard DOC resolver. That should give some performance advantages over DOE because it's using QUIC rather than HTTPS as the transport. But it's still early days on that, and exactly as with DOE, the resolver operator still has visibility of the queries that a user is generating. So in terms of privacy, you're protected from maybe an observer. You're certainly not protected from being tracked by the resolver operator. So you need to make sure you're happy to trust that operator. Going forward, though, another development called Oblivious DOE is intended to address that problem by obscuring the originator of a DNS query from the resolver operator through the use of two proxies to sort of make sure that the resolver operator can't see where the queries have originated from. That potentially then does give you true privacy, but at the moment in the standard, there's nothing to stop the two proxies from colluding with each other. So it will give you privacy in principle, but unless the current standard evolves somewhat, you wouldn't be 100% sure that there isn't collusion. So you'd still need some degree of trust in the relationship. The Oblivious DOE standard itself has been marked within the IETF as experimental because they're spending more time progressing an Oblivious HTTP rather than Oblivious DOE standard. But there are lots of commonalities between the two. And finally, on this slide, for those people that really want sort of a much greater guarantee of privacy without concerns about collusion of proxies, some of you may have seen that Alex Muffet sort of demonstrating DNS over Tor, which I think he in his usual setup, he'll sort of move between maybe about 10 different resolvers, spending no more than 30 seconds using each one. That gives you much more sort of privacy protection. It's not foolproof, but it certainly makes it much harder to be tracked over the internet. But it's not for the mass market. It requires a degree of expertise in the setup. And also in terms of speed, there is a sort of a speed privacy trade-off. So I think, if I recall, Alex was suggesting he was getting sort of average responses of about 250 milliseconds, which he felt from a user experience was perfectly acceptable. But that's a long way off the sort of 5 milliseconds or so that you might get with an on-net DNS resolver. So there is a trade-off, but that's pretty normal in terms of if you want more privacy, usually speed is the compromise. Next slide, please. It's also worth mentioning in this that I talked about Oblivious DoE, which was sort of developed mainly by Apple, which recently brought to market its private relay service, part of the iCloud Plus portfolio that uses Oblivious DoE. So within it, so it uses two proxies to hide the queries from the destination address, as can be shown on the diagram on this slide. So the traffic's encrypted. Apple manages the ingress proxy. A range of third parties manage the egress proxies. Apple can see what where the query originated from, but not what the content of the query is. The egress proxy can see what the content of the query is, but not where it came from, and the two proxies sort of trade traffic with each other. It works. I've had feedback from people saying that performance can be a bit hit and miss. So again, there is a performance trade-off on this. Not everything works well. So not all websites work well with private relay, and it does raise a number of issues around. From a network perspective, in terms of quality of service, resilience, network costs, network performance, because, for example, Apple's controlling the routing rather than the network, so things like CDNs may be bypassed, so user experience may suffer quite considerably if the user's got private relay switched on, and also some unexpected impacts, such as if you've got zero-rated traffic using DNS, then if a user has private relay switched on, then the traffic won't be zero-rated. It will be metered, so that's worth bearing in mind. It does raise some compliance concerns for ISPs in some markets, and also some considerable antitrust considerations, because arguably if Apple enabled private relay by default, which it doesn't currently, it will become by far and away the world's biggest virtual ISP, with a sort of dominant market share relative to anybody else. It also raises some sort of centralization and other issues. If you're interested in that, there's a link on the slide to a report with more detail. Next slide, please. The other topic I wanted to just signpost at this stage, which is currently very topical, is something called Encrypted Client Hello, or ECH. That is an extension to TLS 1.3 and encrypts the server name indication or SNI data. So ECH used to be sort of known as encrypted SNI or ESNI. The sort of draft standard has been developed somewhat and has been sort of renamed ECH. It's still very much at the sort of pre-standard stage, but interoperability testing is underway between some of its proponents. And so best guess at the moment, I could see that standard being finished at the end of this calendar year, maybe at some point early next calendar. Again, that raises a number of issues from the perspective of public or private network operators. So, for example, UK schools are required to operate content filtering. That generally uses SNI data to help with the filtering. ECH bypasses that filtering, so that's a concern for UK schools, because that's a regulatory requirement in the UK. For them to operate content filtering. Again, zero-rated traffic. A number of ISPs use SNI data for zero rating of traffic, such as for NHS type traffic. So again, for people with limited data plans, say on mobile, it could see them eat their data caps if they're using ECH. And in environments where you absolutely have to be sure what traffic users are accessing, such as in regulated environments, for example, then the alternate to using SNI is actually far more intrusive software on the end user devices. So ironically, because ECH is intended to improve privacy, you may actually see a decrease in user privacy on devices to overcome its protections, ironically. It also does raise significant cybersecurity concerns on enterprise networks, because if you can't see what data is traversing the network, that could be command and control traffic for malware, for example, that's exiting your network. So I know a number of major suppliers to enterprises are advising enterprises not to upgrade to TLS 1.3 to avoid the risk of client software running supporting ECH. And again, it does raise some antitrust concerns, and there's a link on the slide to a report which expands on those. Now, we raised some of these concerns at the ITF 113 event in Vienna a couple of weeks back. It's fair to say that the ITF community as a whole wasn't interested in spending too much time considering the user impacts of introducing ECH. But in fairness, since then, Google has announced it's changing, at least temporarily, its approach to supporting ECH in the Chrome browser. It was originally planning to switch it on in Chrome and then forget about it. So no ability for the user or network controller to switch it off. It's now paused that approach, is allowing it to be disabled, and is seeking feedback from users. So if you have any thoughts about how ECH should be supported on client software, then you can certainly take part in the consultation that Google is running to give them your views whilst the opportunity is there. Next slide, please. Now, I think part of the problem here is we're trying to, through sort of effectively end-to-end encryption, trying to use technology to solve the problem of privacy. In my view, that will take us so far, but it certainly won't solve the problem. And also, a lot of the software that's being developed is being developed from the perspective of the US market, in fact, largely from the Silicon Valley perspective, and setups in places outside of the US vary significantly. And if I'm honest, in the standards community, in the ITF, the voice of end users is extremely quiet. So we often see things that have been developed that actually break stuff without the implications of that being fully considered. So things like network management, cybersecurity, and so on, and certainly centralization and antitrust issues. And ironically, a number of the techniques being developed are actually extremely helpful for malware developers, with Dove, for example, being adopted very early by the malware community. So really what's needed is for, if you like, some of the sort of the softer aspects to keep pace with developments. So regulation and legislation, dare I say it, in this environment, to actually keep track with some of these developments, and also think about things like the privacy and transparency policies of suppliers. Next slide, please. And with that in mind, again, a lot of those privacy and transparency policies that tech companies use, again, are often written from the perspective of the US market. And of course, the US doesn't have a sort of federal GDPR equivalent. There are a couple of states with privacy policies, but privacy legislation, but certainly not US-wide. You've got concerns around the US Cloud Act, FISA 702, etc., which blow apart, in my view, any privacy for non-US citizens anyway. And a lot of the privacy policies are very fragmented and difficult to understand. So in the context of resolvers, a year or so ago, we developed the European Resolver Policy. And you'll see the link to the URL there. If you run a resolver, I'd commend you to go look at that. That is GDPR compliant. It does explicitly say that you shouldn't monetize personal data of users, clearly states what jurisdiction you're operating under, etc., etc. So it deals with a lot of the issues that many of the US privacy and transparency policies don't handle well, in my view. So if you run a resolver, please take a look at that. It's free to use, and it'd be good to see more UK resolver operators take that on board. Next slide, please. So I'll finish there. You'll see I put some links in this last slide to the ITF ADD working group for Resolve Discovery. We have a weekly call talking about developments in encrypted DNS and related matters, which you're welcome to join. It's free to take part in the conversation, and some links to other stuff around private relay and ECH, etc., including the bottom of that slide to the Google public consultation on how to support ECH within the Chrome browser. Next slide, please. So with that, I'll stop and hand back to you, James, see if there are any questions.
Thanks, Andrew. That was very interesting. So I'll start within the room. Are there any questions in the room? If you do want to ask a question, you can come up to the microphone. Don't be shy. No? Okay. Kathy, do you have any questions on Mattermost? Okay. No questions. So in that case, I say thank you very much, Andrew. That was very interesting. I think if people do have questions, Andrew's probably in the Mattermost chat room for a bit longer, so you can pop them in there. So thank you very much, Andrew.